Alright, so today we will start with MBC 304. So MBC 304. Now the course title here is amino acid / protein metabolism. So amino acid / protein metabolism. Okay, now as a start, okay, let me just give you a rough outline of what you should expect from this course. So outline. So an outline, we will need to give an introduction to amino acid, introduction to amino acid. We need to talk about classification of amino acid, classification of amino acid. Then after classification, we should be able to discuss some reactions that amino acid undergo, or let me just say what we call transamination reaction. Transamination reaction. We should be able to discuss deamination. Then we should also be able to discuss the urea cycle. Then after the urea cycle, we should be able to discuss before one carbon metabolism, we should discuss metabolism of each amino acid. Then we should be able to talk about under this metabolism of each amino acid. There are a lot of things under that one, but as we proceed, I will walk you through them. Then we should be able to discuss one carbon metabolism. Okay, so like I said we should give an introduction first to what? To amino acid. We should classify amino acid. We should talk about transamination. We should talk about deamination. We should talk about urea cycle and the likes. Okay, so for today now, I should do this one and this if time permits. Alright, so let's start with an introduction to amino acid. What's amino acid? When we say amino acid, what do we mean? So amino acid. So when you hear the word amino acid, what comes to your mind? To define it very simply, we can say that amino acid are the building blocks of protein. They are the what? They are the building blocks of protein. Building blocks of protein. Then also meaning, if I have a protein, imagine this is a protein. The tiny things that make up that protein is what we call amino acid. Meaning, this is an amino acid, this is an amino acid, this is an amino acid, this is an amino acid. So amino acid are the monomers, the building blocks of protein. That is the general definition. But if we want to look at it structurally, we will see that inside an amino acid, there is an amino group and an acidic group. I will show you that shortly. Alright, so let me give you the general structure. In the general structure of an amino acid, you will see a functional carbon. You will see the amino group NH2. Are you there? I will see the acidic group COOH. Then I will see hydrogen. Then lastly, we are going to see arrow side chain. Amino acid. acid. This is the amino group. This is the acidic group. Are you still there with me? Alright, I said if we want to define amino acid generally, we will say it is the building blocks of protein, but that is market definition. Come down to structural wise, what is an amino acid? You said it is a structure that contains an amino group and an acidic group with a variable side chain. This side chain that varies inside an amino acid. So for example, now there are over, mind my words, there are over 20 standard amino acid. There are 20 standard amino acid, 20 standard amino acid. However, there are lots of amino acids, more than 300 amino acids that are there. But when we talk about standard amino acid, mind you, I know what I'm talking about. Standard amino acid, there are only about 20 of them, only 20 standard amino acid. Now, why do I call them standard amino acid? I will tell you at the end of the video. But let me just ship in something. Remember we said that this is the general structure of an amino acid, right? And we said that every amino acid that we draw, we have this general structure. Are you there with me? What we differ will be this arrow side chain. This is the only thing that we differ. So I will draw just one amino acid, I will draw another one. Then you will see that the only thing that differs is this arrow side chain. Let's go ahead. So here is your functional carbon. I want to draw glycine. Then here is your what? Acidic group. Is that also? Here is your what? Amino group. Amino acid. Is that also? Here is your what? Hydrogen atom. Then your arrow side chain. If I should put H here, do you know what I just drew now? This is the simplest amino acid, and it is called what? Glycine. It is called what? Glycine. So when you hear people talk about glycine, this is the structure of glycine. This is the general structure of an amino acid. Then also, but now I replace the arrow with what? With an H. This now make it special. We now call it glycine. Alright, so now let me draw another one. I will still follow the same pattern. Amino acid. So I will follow the same pattern. Again, I will take my functional carbon. Is that also? Then I will put amino here. Then I will put acid here. You can put it anywhere you want. You get. Then I will put my hydrogen here. Then down here is a functional group, right? This time around, I will put CH3. What do you think I have drawn now? I just drew alanine, which is the second amino acid. Are you following me? You get it, right? So this is alanine. So as a way of introduction, I've told you that an amino acid is the building blocks of protein, but structurally wise, we will say amino acid is a structure that contains an amino group and an acidic group with hydrogen and a variable group. If that variable group, which is arrow, is CH3, what you get is alanine. If you put H there, what you get is glycine. Are you there with me? All right. Okay. Let me now proceed to the next thing we have on the outline, which is classification of amino acid. Let's do the classification of amino acid. So classification of amino acid. Are you there with me? How do we classify amino acid? Now, I will be frank and sincere with you that the way we classify amino acid is under 4 headings. There are 4 bases in which we use. So I will say number 1 basis is what? 1 based on what? Based on structure. Based on structure. Are you there with me? Number 2 basis is what? Based on the nature of side chain. Based on nature of side chain. Are you still there? Number 3 basis is based on essentiality. Essentiality. Are you still there? Then number 4, I hope there is space here, but I will just say it, based on metabolic fate. Are you there with me? Based on metabolic fate. That is, these are the 4 bases in which we classify amino acid. So I have 20 amino acid. I want to classify them. First of all, I will classify these 20 based on structure. Then I will classify the same 20 based on nature of side chain. I will classify this same 20 based on nutritional essentiality. Is it essential? Lastly, I will classify based on metabolic fate. Are you there with me? Alright, let's start with the first one. I don't think this video will allow me to finish everything, but we'll start with the first one first. Alright, now based on structure. So based on structure, based on structure, based on structure, we have an amino acid. There are 7 classifications. Okay, basically we have just 2 here, 2 major groups. Here, you see that an amino acid is aliphatic. Aliphatic, I believe you know this from your organic chemistry, or it is aromatic. Are you still there with me? Based on structure, there are only 2 classifications we can think about: aliphatic and aromatic. I believe you know what aromatic means. It means it has a benzene ring. Are you still there? Aliphatic, on the other hand, does not have a what? A benzene ring. That's just the general idea. Alright. Now, aromatic amino acid, there are only 3 of them. I believe you know them, but if you don't know them, I will just tell you. The first one here, we have phenylalanine. Phenylalanine. The second one is called tyrosine, and the third one is called tryptophan. Tryptophan. Seems like somebody took a trip to fan. Actually, that is not the case here. Tryptophan. Alright. Remember these 3 amino acids, they are the only aromatic amino acid, meaning if here is 3, that means here will be what? 17. Now these 17 amino acids that are aliphatic, they are further broken down into various groups. Are you still there with me? Alright, let's proceed. The first group under the aliphatic is what we call simple amino acid. Meaning, if we are to draw the structure of this amino acid, we are not going to see any branches. They are just simple amino acid, that is simplest amino acid. I believe you know them already, so I will just put them here. You want to tell me something like what? Like glycine. Is that not so? And the second one I drew, alanine. Very simple something. They are the simple amino acid. Let's go to the second group here. We now have what we call branching amino acid. Branching amino acid. Do you know this one? I believe you don't, but I will still tell you. The branching amino acid is what we call, the first one we have lysine. We have isoleucine. Are you still there with me? And we have what? We have what? Valine. We have valine. Now, how do you remember this? Of course, keep on repeating it. Leucine, isoleucine and valine. Leucine, isoleucine, and valine. They are the branching amino acid. They have branch points in their structure. Are you there with me? Alright, but there's an easier way to remember it. I will just tell you for free. You can say Lucy branded Valentine's idea. So there's somebody called Lucy. He branded somebody else's idea, which is Valentine's idea. Lucy here stands for leucine. Branded stands for branching amino acid. Valentine stands for valine. And idea, I believe you will say, stands for what? Isoleucine. Is it clear now? So anytime you think about branching amino acid, what should come to your mind is what? Lucy branded Valentine's idea. Very simple. I'll move further now to tell you the other members of the group. We have group C. Now for group C, let's take the OH containing amino acid. OH containing amino acid. Containing amino acid. There are some amino acids that contain OH in their structure. What are they? They are serine and threonine. Serine and threonine. Serine and threonine. Another way that we put it for you, that we say the alcohol containing amino acid. Alcohol containing amino acid. I believe you know them already. Serine and threonine. The question is, how do you remember this? It's always the remembering part that is the challenge. Now I remember this, of course, by knowing that alcohol, are you following me? Alcohol is a serious threat to life. Is that not so? A lot of person drink alcohol and they come down with a liver condition, liver disease. So it's a serious threat to life. What am I trying to tell you here? I'm trying to say that serine, which is serious, threat, which is threonine, they are alcohol containing amino acid. Alright, if you get up to this point, then let's proceed to another group. There's a group called sulfur containing amino acid. Sulfur, they contain sulfur. So sulfur containing amino acid. All these ones we are discussing, they are under aliphatic. Is that not so? Yes. So this one I will just tell you, time is far spent. I will just spill it out. We have what? Methionine and cysteine. Please know this guy. So methionine and cysteine. When we move into the metabolism of this amino acid individually, you will get more understanding. Why I call them sulfur amino acid. Are you there with me? They contain sulfur, methionine and cysteine. I believe you don't need a mnemonic for this, but if you do, I can give you one. There are some people that are called martyred sisters. Martyred sisters. People who die for a faith, they are called martyred, right? I can't spell it sharp, but martyred sisters. You know them now. They die. Or let me not say they die. They will not just kill them by a gunshot. Rather, they will suffer them. So martyred sisters suffered before their death. Their death. That's how a martyr is. Now, they will not just put a bullet to your head most of the time. So will torture you, they will suffer you. So martyred stands for methionine. Sisters, although it's having S, but cysteine, sisters stands for cysteine, and sulfur stands for sulfur. I believe it's very, very simple. Methionine and cysteine, they are the sulfur containing amino acid. Now there is one amino acid. Let me change my pen. There's one amino acid that is called amino acid. Amino amino acid. This amino acid is what we called, there's only one example here. It's called proline. Amino acid. Are you still there with me? The reason why it's called amino is because if we are to draw the structure, it is not having a free NH2 group in its structure. The NH2 group, like the previous one we draw, is not free, rather it is bounded with something else. Are you still there? All right, let's proceed. This is group E. Okay, let me give you group F. There are some amino acids that are called acidic amino acid. Acidic amino acid. I believe you want to tell me them. I will just give you straight. This video is already past 20 minutes. So I'll give you straight. We have glutamic acid. From the name you can tell glutamic acid and aspartic acid. Aspartic what? Acid. I believe you've heard of these guys before. They are acidic amino acid. But is that not funny? Acidic amino acidic. Do you get what I'm showing you now? This is an amino acid with an extra COOH group. That's why it is called acidic amino acid. So if we are to draw the structure, you will discover that there is an extra COOH group in the side chain. Clear, right? Okay. Another way you will see them is that we call them glutamate and aspartate. So don't forget to, if you don't see glutamic acid, you will see glutamate or you will see aspartate. They are the same thing, just that these ones have lost the proton. Okay, you know, when an acid lost a proton, instead of you to call it, let's say, aspartic acid, you call it what? Aspartate. Instead of you to call it acetic acid, you call it what? Acetate. That is by the way. So the last group is the amide containing amino acid. These ones, if you know the acidic amino acid, you can know the amide containing amino acid. They basically contain amide group like this in their structure. Should I tell you? Okay, you remember glutamate, right? So instead of you to say glutamate, you say glutamine. You say what? You say glutamine. Are you there? Glutamine. Let me, it ought to be any glutamine. Are you there? Then instead of you to say aspartic acid, you say waiting asparagine. Please don't forget to glutamine, asparagine. They are the amide containing amino acid. Okay, so we end this video here today. When next we come for this course again, we'll continue from that classification and so on and so on. Okay, so today I've discussed what amino acid is, how they are classified. I told you for the classification we have aromatic and aliphatic. Of course, the aromatic are the easiest one: phenylalanine, tryptophan, tyrosine. For the aliphatic, we have about 7 groups. Please go through the video, know them. I gave you alcohol containing, I gave you acidic, I gave you amide, I gave you sulfur, I gave you what? Amino, I gave you simple, and I gave you branch. Please just know them very well. So as an assignment for you, I will send you your assignment.